Good evening. My name's Jeremy Spitzig. I've been a developer with Cardinal for about 5 years now. And I'm going to talk a little bit tonight about TensorFlow and just give a couple examples of a couple things you can do with it. The first question you might be asking is, what are tensors? Effectively, it's pretty much just basically arrays, just variously nested arrays. The term tensor was sort of stolen from math, and it means something entirely different or much larger than just arrays, but in this case, that's all we really care about. So the dimension, like I said, is just the level of nesting. So for 0-dimensional, it's just a single value in an array. 1-dimensional, it's just your regular straight up array, and then 2-dimensional, you nest one level deeper, and so on and so forth.
So you can have 3 and 4 and 5.
Yeah, exactly. So you'd have yet another. We're not actually getting that deep tonight. It just stays here. So it's a pretty simple concept, but TensorFlow uses them a lot. I mean, it's all of the data in TensorFlow is tensors. It's inputs, outputs, and it just passes them around all throughout it. So now that we've started talking about TensorFlow, that's the next question. What is TensorFlow? So a few years back, when Google was trying to improve some of its products, like voice recognition and so forth, it developed a product called Disbelief. But it was internal, it was closed source, it was proprietary, and they sort of got it working and made a lot of improvements with it. And then when they finished with that, they said, well, let's go back, let's take a step back. Let's try to make this a little more reusable, make it available, so we can make it available to the public. So they went back, they sort of retooled it, they did a lot of refactoring and improvements, and open sourced it under the new name, the new moniker, TensorFlow. So their goal was to make it easy to build machine learning applications and solve machine learning problems. So what the approach they take is to model the problems at a very high level. So you're just describing the relationships between variables and the operations that are performed on them. And then TensorFlow does all the heavy lifting of actually mapping that to CPU resources and computation and so forth. So it's actually, while it's very low level and actually performs CPU operations sort of more directly, there are a lot of language or a couple language bindings provided for C++ and Python. I'm going to go with Python tonight because the C and C++ library documentation is abysmal. Like, it doesn't exist. For the first example, the problem we're going to try to solve, we're going to take in just a large set of randomly distributed points of data, just X, Y points out on a plane. And then what we want to do is try to fit a line to those points that generally matches the approximate slope of the points. It's a problem you often see in statistics and sometimes physics and so forth. So the approach we're going to take is we're going to tell TensorFlow that that's what we want to do, then feed in the data points and tell it, hey, solve this problem and give us that slope and intercept that we're used to seeing, just the standard equation of the line, right? So let me go ahead and pull up some code. All right. First thing we want to do is get together a collection of data points, right? So these are this. Do I need to bump that up, don't I?
Yeah, that's a lot better.
All right. This is not an eye test. So this first step here, we're going to load up our training data, which is basically just a bunch of random X's and Y's. It's generating just an array of 100 100 x's, and then generates sort of matching random y's with them. Then the next step, like I said, we're going to describe the problem to TensorFlow. We want to tell it what we're trying to solve. So we've got a variable here, m, that's our slope. Oh, you can still see back when I had it called w. And b is our intercept. And then we tell it y is m times our x data plus b. And what we want to solve for is this m and b, right? Now, as it stands, we've got two variables. And there's quite a number of solutions that could happen, or that could be found for those two variables. So we also want to add an additional restriction. This is what helps TensorFlow actually figure out what it's going to do. And in this case, what we're trying to do is we want it to reduce the distance between the data, the y data, and the y that it guesses, the y that it uses to build the solution of, the slope and intercept. All right. So then the next bit we do, there's just a bunch of boilerplate there that you just have to tell it to start up, and that's mostly copy and paste between things. So the next thing we do is run over our training data. We're going to run over, I think we're actually 200 x's. Anyway, so we're going to step over all our x data, pass it through step by step, and let TensorFlow figure out from that what the slope and intercept should be. All right. So now let me go ahead and run that and show you what it looks like. All right. And there we go. There's all our random points. And we've got a line that looks pretty much like what you'd expect. So that worked pretty well. But honestly, it's something that you can solve pretty easily with more traditional methods. You don't really need an AI library for that. So I wanted to do something just a little bit more complicated. And what we're going to try to solve is take an image of a handwritten digit from 0 to 9 and figure out what that handwritten digit is. To do that, I'm going to use the MNIST database of digits. It's just a giant thing of images. They're in a special format, but you can see there's kind of a selection. It's really just a bunch of random images of handwritten digits of different ways of writing digits. So to do that, we're going to try to find a pair of tensors, W and B, that we can use to classify images. We're going to make X a big array of pixels, or big tensor of pixels. And our output will be the probability that it's any of a tensor that shows the probability that it's any of the 10 different digits. So the equation ends up being very, very similar to what we saw before with the line. It's just using doing a multiplication of our x's, the w, which is the bigger tensor, and then b is just adds a little fudge factor. And softmax is what turns it into a probability distribution. We're going to end up with values that aren't, and it sort of forces them to look like probabilities. All right, so again, we're going to load up our training data. There's the set of images that I was talking about. And then tell TensorFlow what we're going to try to solve. We've got a couple variables. The x's, placeholder just means that's where we're going to feed in those images. There's the softmax I was talking about. And this y underscore is the outputs. So again, like we had with the linear equation, we need one additional thing to sort of tell TensorFlow how to solve the problem, because otherwise it's just left with too broad of search space, sort of. So we're going to use this thing called cross entropy, which I'm not going to talk about in detail, but that does that step of forcing it within a range. Okay, and then more of that boilerplate I mentioned before. That's just a few things that you have to do to get it started. And then finally we're going to actually, so step one, we're going to go ahead and train this thing and generate a model that can recognize digits. All right. So let me run that. And it chews for a little bit. And what it spat out there is basically how accurate the model is. It's about 91% accurate. Now, that might get you an A in high school, but with this, that's really not that great. For our purposes, it's good enough. But if I wanted to actually have a good one, it would take a lot longer, it would run for a lot longer, and require a lot more code, or a fair amount more code. All right. But now that we've got a model, let's go ahead and test it out. So let's see if we can get it to recognize a 9. Yeah, thinks it's a 9, about 66%. All right. Something, let's give it an easy one. Yep, it's pretty sure that's a 1. Right? So basically, we've got a working model now, and you could run, you'd write digits from 0 to 9 to your heart's content. That's about it. So thanks for your time. A couple resources. The TensorFlow website has some tutorials and all the API documentation. And if you really want to look at the actual source code, they've got it up on GitHub. And there's also another GitHub repository that's got some additional tutorials that might be helpful. Right. Do you guys have any questions?